you're comfortable with to, help you in one thing or another. So Mr. Rugwama is there, and he's going to take you through the class, through the lesson. Mr. Rugwama. And wait for things to pile up. You get me? Every teacher's number. So you just inbox that teacher and ask. Okay. So me, I'm leaving. Mr. Rugwama is the host, and he is going to teach you. You can see he's trying to look for network. Okay. Let me leave. We shall meet tomorrow. For the new members, I've seen some new members today. Thank you for joining us, and please encourage your other friends to join us. Okay. Don't be selfish. Inform your guys, your friends, to join the Zoom classes, and you'll benefit from this. I'm very sure by the time you go back, you'll be you're going to be promoted. That is what is in the news. You are going to be promoted senior 6, but with the what? Remember, most of you studied for 2 weeks. Others were just looking for schools to start to join. So if you use these sessions, I'm very sure you'll go back when at least you are well cooked, not half cooked. To be what? Okay, guys, let me quit, and your teacher will be right there. Just a few minutes. I think he has tried to settle with the network and is looking for a better place that is convenient to teach you. Yeah. So have a nice day. I'll meet in other lessons. For those who don't know me, I'll introduce myself there. Bye-bye.
Okay, so I guess finally I'm here. Yes, please.
Yes.
Mr. Kasacha.
I'm now leaving. You can.
Okay, thank you for holding them up.
Continue with the class.
Okay, guys, we are under Newton's laws, and we're advancing to connected particles. And today I want to discuss case 1, connected particles. The rest you should unmute. Mute yourself. Kasacha, mute. Tusime, mute. Tashobia, mute. Kasacha, why are you unmuting? So, we are saying we are looking at what we call connected particles. For the newcomers, I'm Mr. Rugwama Hamza, and I teach here math and physics. So we shall be meeting in those 2 areas. So I was saying case 1 for connected particles, we are going to consider a simple pulley. This is called a simple fixed pulley. Nicole, mute. Kasacha, mute. I'm muting people, but they're unmuting. So we can have masses M1, M2. These masses will experience what we call weight of the body, which is M2G. This one will experience M1G. Then they will also experience tension in the strings. Now, if I assume mass M2 is greater than mass M1, then basically M2 is expected to go down as M1 is expected to go up. So for that reason, they are going to be moving as the pulley rotates with an acceleration small a. Now, as to get resultant force, remember, last time I discussed on how to get resultant force, that if you have a driving force which overcomes friction for a mass capital M, G, then the driving force is overcoming F to give us MA, the resultant force. So even here, if M2G is going down, then M2G overcomes the tension to give us M2A, which is the resultant force acting on mass M2. When you come to mass M1, it is going up because the tension in the cable T is overcoming M1G. This is going to give us M1A. Now, these are the two basic equations that can be describing a simple fixed pulley. And with these two simple equations, they can ask you also to find the reaction on the pulley. Now, we can use simultaneous solving methods by addition of Roman 1 added to Roman 2 to solve simultaneously. When I add this to that, the negative T adds that with the positive T, you get a 0. Then you'll have M2G minus M1G to give us M2 plus M1 because I have added A. So with this, acceleration will become M2 minus M1 over G, close brackets, all this divided by M1 plus M2. Now, with that illustration of getting acceleration, we can substitute acceleration in the formula for tension, where tension is equal to M1A plus M1G. If you look at this one, you take the M1G this side, you will have M1G plus M1A. Therefore, tension shall give me M1 into acceleration plus a G. So when you substitute, algebra will become M1 into M1 minus, M2 minus M1. This one has a G divided by M1 plus M2 plus another G here. I am substituting for acceleration. So I can factor out G to give me M1 G into big brackets, M2 minus M1, close brackets, over M1 plus M2 plus 1. So carry out the algebra and simplify. We shall get M1G into big brackets, M2 minus M1 plus M1 plus M2. All this divided by, we are simplifying the fraction and the whole number, M1 plus M2. So M1 dies with M1. So we are going to get twice M1, M2 over G over M1 plus M2. And with these diagrams, we sketch them with a ruler. Now, this one is in terms of a derivation. But if it comes in terms of numbers, it is also possible. They can ask you to do that derivation in this case to show that tension is that. They can bring a number which has figures rather than letters. So reaction at the pulley. Since the pulley is not moving up or down, Then tension, you look at the direct forces acting on the pulley, one of which are those two tensions and the normal and the reaction here on the pulley. So because the pulley is not moving up or down, the resultant force acting on the pulley is 0. So the pulley has a reaction which is equal to T. So with that note, the reaction on the pulley will actually become 2 times 2m1 m2 g over m1 plus m2. And this answer gives me 4m1 m2 g over m1 plus m2. So that one will guide us on getting how we find the reaction on the pulley. Now let's take a look at an example in this case so that you clearly see the picture from the word go. They give you a simple pulley. And then they give you masses attached to the ends. Maybe this side we have 2 kgs. This side we have 1 kg. So 2 kgs and 1 kgs. Yeah? 2 kgs and 1 kgs are kilograms. So you can convert these masses and attach their weights. So the weights acting due to these masses are 2 g newtons and 1 g newton. When you're sketching these diagrams, you have to attach those forces by drawing them using a ruler. Now, you'll find that we expect tension here and tension there. Now, some of you, if you meet some books, you'll see that tension is represented like this with the 2 arrows. Now, if I move this arrow, if I'm to move this arrow and I bring it here, you'll see that it is bringing out a concept like that one. The same, if I move this arrow and I bring it here, it will face down. So it is the same ideology. So even if you put 1, as long as the reason why we need to put 1 or we put 1, it's because we need to avoid the confusion. Some students get confused with the arrows. When you put 2 of them, they don't get to know which right direction is the tension acting. Now, with this, we also need common sense. The bigger mass is 2 kgs, bigger than 1 kg. So when they say the system is released from rest, it means if it is released, 2 has to go where? Down. So the pulley rotates this way with an acceleration A. Here it's raising up. So here the mass of 1 kg is going upwards. So 2g minus the tension is equal to 2a. So the resultant force acting on the 2 kilogram mass is, because when forces are acting in opposite directions, we subtract to get the resultant. That's why we are subtracting 2g minus t. For the other one, when it's going up, tension overcomes 1g to give us 1a. So I have equation 1 and equation 2. When you add these 2 equations to solve simultaneously, you will have g is equal to 3a. Because the negative t plus the positive t, they give you 0. Thus, my acceleration a is 1/3 g meters per second squared. They don't tell you to leave g in your answer. Then you have to always go and substitute for g, where acceleration is 1/3 times 9.8. This will give me 3 point. When you press the calculator, 9.8 times 3. For physics, you use that 9.81. For math, we use 9.8. So since we are in math, let me remove the 1. What do we have?
Three point
3 point?
7.
3 point what? 2. 3.2. 3.2 what? Guys, what answer do you get? Now we can go for tension also. Tension minus 1G is equal to 1A. So tension is equal to 1G plus 1A, giving me a G plus a third G. This will give me 4G over 3 newtons. Can you get this in terms of values without a G? What answer do we get? Guys, press your calcs, those with calc. If you don't have a calculator, you download the app for a calc called the Real Max Scientific Calculator. So what do we get?
13.067
Newtons. Now, having gotten the tension, they can ask us to find the reaction at the pulley. We saw that the reaction at the pulley is always twice the tension. So R shall give me twice times 13.067. What do you get?
$26.13.
Eh? We get
26.134.
26.134. Okay. Now, some of times these numbers will not come obviously like this one. That a diagram is there. If the system is released from rest, find the tension and the acceleration. They might set for you what they call a word problem. And that word problem can be mixed with linear motion. So download that and look at an example of that kind.
Aida, Bambi.
Hello? Hello? Why'd you say? Tebakola ki? Ate kulwaji lwema ki? Nabukenya namuweereza password bw'aba tezikola ddemu ampeereza ambuulire wanze ndi mu class. Ese nazimuweereza. Naye alina okuba nga ali mu kibiina, aba tali mu kibiina baleka bancontacting ku WhatsApp kuba kati nze ndi mu kiraasi. Yeah, I've seen another number here which is going to be quite a good example on word problem. So let's have example 2. Bodies of masses 6 kgs and 2 kgs are connected by a light inextensible string which passes over a smooth fixed pulley. With the masses, who is this one? Hanging vertically, the system is released from rest. Find the acceleration of the system and the distance moved by 6 kgs mass in the first 2 seconds. So here we are. 2 bodies of masses 6 kgs and 2 kgs are connected by a light inextensible string which passes over a smooth fixed pulley. With masses hanging vertically, the system is released from rest. Find the acceleration of the system and the distance moved by the 6 kg mass. Now, that is what our number says. It was a wordy problem, so you have to be in position to interpret the question and apply the math. That's why this paper is called Applied Math. So this can be 6 kgs, this can be 2 kgs. Whereby here we shall have 2g newtons, here we shall have 6g newtons. Tension, tension. Common sense, the 6g goes down, the 2g has to go where? Upwards. So equations, 1, 6g newtons minus tension is equal to 6a. Tension minus the 2g is equal to 2a. When you simplify this and eliminate, we shall have, add the negative t to positive t, you get a 0 plus 4g is equal to 8a. With this, our acceleration is a half g meters per second squared, which is the same as 4.9 meters per second what? Squared. If they ask you for the tension, tension would have been 2g plus 2a, which would be 2 times g plus 2 times a half g. Then the half would be lost, and the tension will give us 3g newtons. But 3g newtons is the same as 3 times 9.8. 3 times 9 is 27, 3 times 8 is 24. The answer is 29.4 newtons. Now, the question did not want tension, basically, but because of the discussion purposes, I had to talk about it. Now, they want us to find the distance moved by the 6 kilogram mass in 2 seconds From equations of motion, S is equal to ut plus a half at squared. Now distance shall be 0 plus a half times a half g times how many seconds? 2 seconds. So this will give us displacement as a quarter times 9.8 times 4. So it will have moved in actual sense 9.8 meters. That's why I was saying time is going to come when these numbers, they are going to mix them with linear motion or with motion. So here they are telling you what distance did it travel. They can bring another number whereby one can go, stop, or land on the ground, then the other one continues for some time. Then they ask you how further more does it travel. I wish I could see one of that kind so that you also take a look at it. But with that, you can have that down. Unless if someone has a question. I'll see if I find the question. I'll either send it or if time allows, I can also do it here. There is a case 2, which is motion on a table. You know, weight of the body always acts vertically downwards. The cable is the same. So tension is the same. Now, if the table is rough, it will have what we call frictional force. Whereby frictional force is got from mu r, where mu is called the coefficient of friction. Where R is the normal reaction. And the R is actually equal to M1 G. So when motion is taking place, we shall have horizontally, tension overcomes the frictional force to give us the resultant force on M1. Then for vertical motion, this one is going down. Maybe you're unlucky. Newcomers, did you come with the bad luck of innate work? Which newcomer came with bad luck? Anyway, I was looking at case 2, where case 2 we are saying we are looking at a table which table has some masses, M1, M2, and I was saying we have a reaction here, and the frictional force is mu R, where R is ideally M2G, and mu is the coefficient of friction. Coefficient of friction lies between 0 and 1. Then I was looking at motion horizontally, tension overcomes frictional force to give us M2A. Because the pulley is rotating like this, with an acceleration small a. Then vertically, M1G overcomes the tension to give us M1A. Give us equation 1 and equation 2. When you add these two, you shall get M2G minus F is equal to M2 plus M1 times A. Therefore, acceleration will become M2G over M2 plus M1 minus F. But if the table is smooth, then F will be 0. It will not be rough. Friction occurs for rough surfaces. Then here acceleration will be M2G minus M1 plus M2. Also here they can ask you for the tension, so you get this acceleration, drop it either here. Tension is equal to M1G minus M1A. From here, tension crosses over, M1A goes the other side. So tension would become M1G minus M1 into M2G over M1 plus M2. This will give me M1G into M1 plus M2 minus M1 M2G. All this is divided by M1 plus M2. Simplifying this further, we shall get what? M1 squared G plus M1 M2 G minus M1 M2 G over M1 plus M2. So the tension becomes M1 squared G over M1 plus M2. So That is how a table can look like. So having seen the definition for a table, we are now liable to look at it, and now looking at a number for a table. So download that, I get your number here for a table. Oh, I'd forgotten one thing. They can ask for the reaction at the pulley. That reaction will be here. You can call it RR. The resultant reaction. So R, a smaller r, is what we call the resultant reaction. So the tension at the pulley is going this way. Another tension is going where? Down. So another one is facing up. So we sketch what we call an appropriate right angle triangle, which will look like this, and the other like that. So the resultant reaction, this is 90. So the resultant reaction would be square root of t squared plus t squared, giving us t root 2 newtons.
Oh, I've got it.
Hey, here.
Yes.
You see that?
Yes.
Is it okay now?
Yes.
Teacher,
Yes, please.
is gram newton the same as kilograms?
Ah, where have you seen it?
Here where
Newtons are newtons, grams are grams. Newton is an SI unit, gram is not an SI unit. So the units for tension are newtons, while the units for mass are kilograms. So if they give you a number in grams, convert to kilograms.
So I think she means the G.
Hey, a number like this
Yes.
one, eh? This one, eh?
yes.
There we are just getting the tension in terms of acceleration due to gravity. Okay? That's why sometimes I say if
So
you
it's
don't
not
get,
that
it's not that G is a gram, no. G is acceleration due to gravity.
okay, teacher.
Yes. Okay, let's have a number.
The second sentence is not clear.
Pardon?
The second sentence.
M1 lies on. Lies on a smooth horizontal table and is connected to a freely suspended particle of mass M2 by a light extensible string passing over a smooth fixed pulley. Situated at the edge of the table. Initially, the system is at rest with M1 at distance small d from the edge of the table. Show that acceleration is M2G M1 plus M2. And that time taken for M1 to reach the edge is given by square root 2D M1 plus M2 over M2G. We have a particle of mass M1 lies on a smooth horizontal table and is connected to a freely suspended particle of mass M2 by light inextensible string. Passing over a smooth fixed pulley. Situated at the edge of the table. Initially, the system is at rest with M1 a distance of D from the edge. This is M2G. This is M1G. There's a reaction there. It is smooth, so friction is 0. So tension to overcome friction to give us M1A. But because F is 0, tension is equal to M1A. Then going down, M2G minus tension is equal to M2A. Because M2, T is M1A, M2G minus M1A is equal to M2A. Acceleration is equal to M2G over M1 plus M2. Which is in agreement with what the question wanted. Now here comes part 2. It says find the time taken for M1 to reach the edge of the table. If the system was released from rest, and this is where M1 was, it is traveling a distance D. From S is equal to UT plus a half AT squared. D is equal to 0 plus a half. Times what value of acceleration do we get? M2G over M1 plus M2. Times T squared. So T alone will be 2D. This is 2 squared of M1 plus M2. Divide this by M2G by getting the square root on both sides. Therefore, the tension will become square root of 2D into M1 plus M2 divided by M2G. So hence proof. That is what the question wanted to prove. So we have seen what we have called the single fixed pulley. We have also seen what we call motion of 2 particles on a table. The next definition will be looking at 3 particles on a table.
Excuse me, sir.
Yes, please. Question. Hello? Hello? Yeah, you said the question.
I'm saying I've not understood.
Hey, where? Here on this equation.
Yes.
You know the equation of motion, S is equal to UT plus a half AT squared, not so?
Yes, sir.
The acceleration is defined by M2G over M1 plus M2. Initially, the system was at rest, U was 0. The distance we are traveling to the edge is D. This is the distance to the edge. From here to M of to there, it was D. So substitute D. Let me make T the what? Make T the subject. Is it better now? Guys, are you better now? Is it fine? Is that okay? How do we get? Yes, Eric, what do you get? Is that what you get? You can simplify that on your own by making T the subject. Huh? Okay, so today we are going to stop at those two. We shall have the table with 3 masses next week, which will be either rough or smooth. But I'm going to send some numbers for you to try out. Those from
Yes, sir.
schools which have never seen this also, try those numbers out. And if you have any challenge, post it on the group. If you are new and you're not on the group, you let me know so that I can add you to the group. I've posted some numbers for you to check out. I'm sure that Daniel is coming now. So with that, we shall start from there next time.
Okay, sir.